All right, well, hi, Algebra 1 kiddos. This is Mr. A again, and we are continuing on with our factoring notes. This is the second video that I'm composing for you. We're going to really start looking at how to factor some trinomials now. And if you notice, I have a rectangle here. I give you the area this time, which is x squared plus 5x plus 6, and I ask you to find the dimensions. If you recall from the last topic, I gave you the dimensions and you had to find the area. So we're going to actually reverse last topic's process. And I'm going to show you how to make that happen. Okay, so if this was class, this would be a problem for all the groups to consider. I'm going to go ahead and zoom in on here a little bit. It would be a problem for the whole groups to consider, and then we would get answers from each group, and we talk about them and figure out, what makes the most sense and that kind of thing. I'm actually going to kind of cut to the chase a little bit on this. So we're going to skip this problem here for right now. And we're going to skip this problem here right now as well, I believe. Okay? Actually, I'm going to kind of give you an idea of what's going on here so you can see how this works. All right? Basically, what we have to do is find two factors that multiply, a length and a width, that multiply to the given expression. Okay? So as it works out, what we will find is that there's only one way to get an x squared. Okay, x squared equals something times something. Okay, and the only way you can get an x squared is if the two somethings are x and x, right? So each of these groupings must have an x. So when we use the FOIL method to multiply, x times x is your x squared. All right, so that term is taken care of. So if I multiply this together with this, that equals your x squared, okay? Now, the tricky part here is to get the other stuff here to work out, the other terms in the binomials to multiply to 6, and also add to 5, okay? That's the game here now. So here's the deal. What we're going to do is we're going to list factor pairs of 6 right here underneath the 6. And we're just going to list positive pairs. So, for example, 1 and 6, that's one possibility. That multiplies to 6. And then we have 2 and 3. That also multiplies to 6. Okay? But only one of those pairs adds to 5. Okay? So we're going to add those. That adds to 7. That's not the one we want then. So we'll cross that one out. But if you look, 2 plus 3, that equals 5. So here's the idea. If I add a plus 3 in this group and a plus 2 in that group, then that becomes the dimensions of the rectangle. I'm going to move this over just a little bit so we have extra room. Watch me multiply this back out. All right? So x times x is x squared. Now, the outer terms, x times 3, 3x. Inner terms, 2 times x is 2x, and then 2 times 3 for the last terms is 6. And if you combine your like terms, you get x squared plus 5x plus 6. So the factorization of x squared plus 5x plus 6 is those two binomials. Okay, so it would be, the final answer would be x plus 3 plus x, or times x plus 2. All right, so the game here, what you're going to have to do is find a factor pair of this term that then adds to this term. All right, and we'll generalize that here in our steps in a few minutes. I have steps for you here that you can do this with. All right, and then we'll do a few examples, and then I will let you do a few other examples that you might need to do. So I don't want you to know how to do this just quite yet. We're going to do a few more examples first, but this is the general idea, okay? And notice one more thing before we keep going, before we go here onto the next example. Notice that the coefficient of the x squared is 1, and that is a leading coefficient. If I write the product in standard form, then the first coefficient is what we call the leading coefficient. So the technique I'm going to show you today to factor these trinomials, all the leading coefficients are 1. Okay, so this trick's going to work for all the or this technique is going to work for all trinomials whose leading coefficient is 1, or there's the coefficient on x squared is 1. All right, so if we go back down here to our next example, this one right here, we're going to try to do the same thing here. Okay, so this time the number I'm looking at here, whoops, I needed to do the highlight there, sorry. This is 12, okay, and then the middle term is 7. So I want a factor pair of 12. Let's write that 2 again. There we go, factor pair of 12 that adds to 7. So I'm going to list my factor pairs to 12, so 1 and 12, 2 and 6, 3 and 4. I don't think there are any other factor pairs of 12. Now if we add them, that becomes 13. That becomes 8. I'll write that 8 again there. And 3 plus 4, that's the 7. That's the one that I need. So those first two are out. So those are the two that I don't need. So if I write my two groups, like so, I know I have to have an x in each group, and then one number from the factor pair. So x plus 3 and x plus 4. That's the factorization of that expression. All right, and we're going to do something now similar to this for some additional problems, all right? So let's take a look here at what we have. So this is the general form for these trinomials, okay? So it's x squared plus bx, so the coefficient of the x term is b, plus c. And of course, and if you notice here, it could be plus or minus, so we gotta be careful with that. If you notice that, oops, need the pen. You can see that that's plus or minus there, plus or minus there. Okay, so those signs are not plus signs all the time. They can be minus signs too, and that does affect what factor pairs you're going to want to identify also. We'll talk about that in one of the examples down here in a minute. But let's finish up our sentence right here on the notes that you see. So to factor x squared plus or minus bx plus or minus c, it's real simple. All we're going to do is find a factor pair of c that adds to b. Okay, so there's c and there's b. So we're going to find a factor pair of c that adds to b. Okay. So you can get that sentence in your notes and do the highlighting as you wish and those kind of things. This is a real quick lesson. I'm just going to do a couple of examples in it because once you get the pattern down, you're in good shape for this one. So this isn't going to be too in-depth of a lesson. We're going to get eventually to the point where the leading coefficient of these trinomials is no longer 1. But before we do that, we've got to learn another technique first. So the next video will be that technique, and then I'll do another video, which is the final trinomial technique that works for all trinomials. Okay, so now that you have this down, we'll go ahead and do this first example right here. Okay, and I'll do the actually I'm going to say the first one for you because it's all plus. Let's take a look at example 2 here. Okay, we'll do example 2 and example 3, and then you can say some of the others for yourself. Okay, so let's take a look here first of all, example 2. And our number that we're going to look at here, we'll highlight, it's negative 14. Okay, so I want a factor pair of negative 14 that adds the negative 5. All right, so let's start making a list of factor pairs of negative 14. Actually, move that over just a little bit so I can show the sums as well. Okay, so when you have a negative product, one of the numbers in your pair has to be negative. That's the only way that a product will become negative. A negative times a positive is a negative product. So we have to play around here with the negative signs to see which combination will give us the correct product. We need to multiply the negative 5 or add to negative 5. So we want to make sure that the negative sign is with the right number. So we have, let's do 1 and negative 14. And then we have 2 and negative 7. And we can go ahead and list the others too. All we're going to do is say 7 and negative 2 and 14 and negative 1. Okay? And then we're going to add them together. So when I add them together, I get negative 13 there, negative 5 there, positive 5 there, and positive 13 there. So which one do I need to finish up the factorization? I need this one right here. That's the one where the factors add to negative 5. Okay? So now the rest of it is just putting it in the right form. I'm going to make my two groups. Like so. Put an x in each group. Okay? And then one number from the factor pair. So I'm going to have plus 2, and I'm going to have minus 7. And that's the final answer. It's all finished. Okay? All finished. So, again, you can check your work by the FOIL method and make sure it actually multiplies back to the trinomial. So if I do that real fast, I'm going to do it real quick here. X times x is x squared. And then x times negative 7 is negative 7x. 2 times x is positive 2x. 2 times negative 7 is negative 14. I come on my like terms, and I get x squared minus 5x minus 14. It checks. That's the correct factorization. Okay? Now for problem number 3. If you notice, we have an interesting sign configuration here. My sum has to be a negative value, but my product has to be a positive value. I'm going to give you a minute. I'm going to hit the pause button for a second. I want you to figure out what kind of numbers in my factor pair my signs must be in order to make this happen. A negative sum and a positive product. Okay, so take a couple of minutes and think about it. Hit the pause button, and then I'll tell you the answer. Okay, you should have realized that in order for this to happen, both numbers in the factor pair must be negative. That's the only way you're going to multiply to a positive product, and you're going to add to a negative sum. Okay? Now, we have quite an extensive list of factors of 36, so I'm going to have to probably make 2 rows of these, but we do know that both numbers in the factor pair have to be negative, so that will reduce some of the possible factor pairs that we have to check. Okay? So I'm going to go ahead and start listing some numbers here. And we're going to do negative 1 and negative 36. And we'll do negative 2 and negative 18. And negative 3, negative 12. And we'll do negative 4 and negative 9. And of course, negative 5 doesn't have a factor of 36, but negative 6 does. And it's negative 6 and negative 6. And now I know that I've got them all because that's the closest two together. And here's the other thing. Once you know what factor pair it is, you can stop. You don't have to continue to write down all the additional factor pairs. Once you've found one that works, you're more than welcome to stop and continue on with your problem and go about your merry way. So we know which one it is now. I believe we passed it already. It's negative 2 and negative 18. That's the one that multiplies, or I'm sorry, not multiplies, but adds to negative 20. Okay? None of the others do that. So now all I have to do now is draw my 2 groups. 1, 2. Put an x in each group. And then both of these factors are negative. So it's going to be x minus 2 times x minus 18. And I'm going to draw my box, or my final answer. And this one's finished. Okay? So I'm going to leave you guys problems 1 and problems 4 to do on your own. I think you have plenty of examples on to let that happen. And I'm going to skip here for example 5, because one of the things we always need to get in the habit of doing first is making sure we check for a GCF first. Okay? So check your terms and see if there's a GCF between all the terms. And if you check long and hard enough, you should have realized that your GCF is 2. Okay, so I'm going to actually move this over here. And I'm going to divide each one of these terms by the GCF. But here's the thing. I still have to factor what's left over. So here's what I'm going to do. I'm going to use some interesting grouping symbols here. I'm going to use brackets. That way I know that I still have work to do inside the brackets. So I'm going to do a 2 for my GCF on the outside, but then I'm going to draw a square bracket. And I'm going to have left over x squared minus 11x plus 28. Okay? So what you need to do now is factor this expression inside the brackets. Okay? And when you get that done, you can then leave your 2 on the outside as you factor, because that's a factor in your final answer. Remember, your final answer has to multiply back to the original expression, so don't lose that 2. But then you can multiply the 2 by your 2 factors, okay? And of course, you know, each one of them gets an x, and I'm going to leave you to find the factor pair that works, okay? So watch out for that on your assignments, because I might have thrown a couple in there that you might have to find GCF first. And we need to get in that habit, because that's going to be something that's going to come up here later on anyway. So be sure you always check for a GCF first, even though if I don't specify it in the directions, that's always kind of like a number one thing we always try to do. Okay, and now we're at the place now where we can start doing that. So I believe that's going to give us to the end of this topic. Yep, because the next one's going to be the next video. So again, how do we check to make sure our final factorization is correct? Use the FOIL method on that. This is going to be the end of this video. And in the next video, I'm going to show you how to factor 4 terms, which is going to require you to factor by grouping. Okay? So hopefully this can get you through the assignment for section 7, 5. And then we'll go ahead and take it from there in the next video. All right? Thank you.